All right, I think everybody heard the keynote today from Swami. It's quite amazing, right? All the generative AI stuff. This talk is no different. It's still the same thing. Innovation, 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 right? So welcome to NTA 203, using AWS Serverless for event-driven architecture and domain-driven design. I'm Balachandra Kilapudi, AWS Solutions Architect and a DevOps/systems engineer by trade. And I'm here with Jonathan Luke, Global Director of Software Engineering at Citi, and also Lee Gilmore, Global Head of Architecture and Technology at Citi. I've had the amazing opportunity to work with the Citi team. Please give a big shout out to the Citi team in the front here. So I've been working with them for the past year. And they've been continuously learning and trying to reinvent themselves using AWS Serverless. And today is where we learn a few things of how their journey went in the past year. So with that, here's a quick look at the agenda. So we're going to look at the different benefits and advantages of going towards the EDA and serverless approach. And Jonathan is going to go over the Citi's journey with AWS in the past year. And then we'll have Lee Gilmore going over Citi's architecture. So with that, how many of us here in the room are already users of AWS Serverless or event-driven architecture? Okay, that's a handful. That's very encouraging because 14 years ago, I was super proud of getting my Linux server installed along with the databases configured in the HA mode. And that was amazing back then, writing scripts. And now that's different. The age is transformational of what we can do today with AWS Serverless. All I have to do is focus on my business logic. So with that generative AI and AI-driven era, we as enterprises are continuing to transform our businesses. And in this day and age, it's even more of a greater need to reinvent ourselves. So how is AWS going to help you in this journey, right? If we think about reinventing ourselves, the first thing is we have to think about what is the value we are providing to our customers and how can we reinvent ourselves. It's more of a design question, even before technology comes into the picture. And to get to the design problem question, you first have to think about events. What are events? Events are pretty much everywhere. And to go ahead and innovate yourself, you need to completely understand not just your own product, but your business domains and what are all the events within those business domains. Later on, Lee will touch a little bit more about domain-driven design, but specifically about events. Events can be anywhere, right? Within the airport, where you went through the process of getting a flight ticket and checking in. That's an event, right? And maybe in your hotel, in this check-in process. Customer experiences get defined by events. So this is so fundamental that this day and age of digital software innovation, we as enterprises have the responsibility to do the best for our customers, and events are one way to approach this problem from the bottom up. So with that into the context, let's talk about what Melvin Conway said. Conway's Law, it's very popular, and I come very close to it primarily because as a systems engineer, I can understand what he's saying, right? And we all do. So any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. Why is this important? The more tightly coupled our processes and our teams are, software just ends up being a communication implementation of our teams are set up. And within an organization, it is our leaders' responsibilities to keep it very loosely coupled because that'll end up building scalable systems over time. And this is all taken into consideration from the long term, right? So event-driven architecture is one way to help you promote this loosely coupled architecture mechanism, right? So let's take a look at what does AWS Serverless do for it. Because event-driven architecture is not new. We've been talking about it for a while. But where does AWS Serverless come into the picture, enabling this journey of orchestrating event-driven architectures? The most important thing as a systems engineer I realized is, yes, it was so satisfying to install a server, upgrade a server, doing all of that. But I didn't really care about what was the bigger picture of my business, but rather focused on my own individual focus or the functional role of what I was doing, and I was happy about it. But when I got to know the bigger picture of how I, as an individual, can contribute to my bigger business value, then it all made sense. So that's where I fell in love with serverless and Werner's talks over time, and this is what I see. Like, every single event-driven architecture needs a number of services across event producers, event consumers, and the broker. You can have your team spin up those services or use AWS Serverless. But the best part about it is with AWS Serverless, you get all those services across the board, and you're able to do all of the underlying boilerplate code with very, very minimal effort, right? So that's the beauty of it. Like, it's off the shelf, no infrastructure to manage, and you only pay as you use. And also one more thing that I realize is cost is important factor for most of the enterprises. When something is fancy and complex and too costly, enterprises try to avoid it. They don't want to spend too much, even though it looks fancy, right? But when your developers are unleashed with this freedom of innovation, of getting yourself to experiment really quickly with event-driven serverless model, it becomes very interesting of how fast we can innovate as a business. And that's where the combination of event-driven architecture and serverless together provides us amazing benefits of greater developer agility, scalability and fault tolerance, and lower TCO. So when you think about greater developer agility and extensibility, tightly coupled systems, hard to innovate because feature velocity slows down. You want to understand your entire ecosystem of services and components, and one change on one side of the component affects the other change. So hence, risk is there, and that's why we slow down. And that's just part of the nature of this problem, right? But with the event broker in the middle, as a central event broker, you're now decoupled. So what happens? Any team member within each of those components is free to innovate, and all they have to understand is the event broker itself and the event that they are actually working on. So this is why in the bounded context later on, when Lee explains why we need to have a bounded context, it makes sense to understand what are the events within those bounded contexts. And Taco Bell is an amazing example of this developer agility story. So they realized during the pandemic, they had a sudden surge of orders from online delivery partners. And those orders have to be integrated with the point of sale system in those stores so that the customer orders are delivered, right? Seamlessly. And they were able to achieve it. They were able to do this integration by integrating with those existing systems, not much changes done to those, but having an event-driven serverless approach in creating this API layer to integrate with their point of sale in-store applications. All of the POCs were done within a span of 2 weeks, and within 2 months, this application that you see here was in production. And they were able to scale this by load testing to up to millions of orders per hour, and later on, they also added further integrations with other delivery partners. And the next benefit you see here is increased scalability and fault tolerance. I've been, as a systems engineer, up all night sometimes, running the midnight oil, just to troubleshoot my system that, one small change that brought down the entire system. And that happens a lot. We have all been there. And we want to avoid that. Event-driven approach is one mechanism, because what happens is it avoids this cascading failure effect by having this asynchronous way of communication, right? From the order service, let's say your shipping service has some errors and doesn't respond, it's okay. You still have your responses back from your inventory service. And then you make sure you have the shipping service fixed, and then you're fine, right? So, but the most important thing that we realize is serverless also provides this fault tolerance built into it. Lego is an excellent example of using this approach to rebuild their e-commerce platform from scratch, and then they were able to successfully scale and meet their Black Friday needs. So with that, the final thing is, one of the benefits is lower TCO. We always don't think of cost as the first thing when you're solving a problem, but in this serverless and event-driven approach, it's fundamentally important for us to think like that, primarily because you need to know what are the events that have an impact to the business value. And then you need to know, how do you architect those in a scalable manner? And with event-driven and serverless approach, you don't have no infrastructure to manage. It's all pay-per-use, and you don't pay for the idle time. And Liberty Mutual is an amazing example of it, early adopter of AWS serverless and event-driven architecture. And they processed over 1 million transactions for just $60. So that's amazing, right? I couldn't do it 14 years ago. It's not even thinkable, right? So now taking a step back, yes, we know it's a design problem. We have solved it with the help of serverless and the ability to have things spin up just when we need it. And that's important. But everything starts from the grounds up. You developers have now more freedom to unleash their creativity. And that's where it starts. Because you as business enablers have provided them this platform, which can enable you to succeed more for your customers, right? So that's where you developers get to brainstorm. We even call it Event Storm, right? And that's super important. And Lee and Jonathan are going to talk about it as well a little bit more. And at the end of the day, when you have these loosely coupled teams and products coming together, it's going to enable greater business innovation. And even, for example, generative AI tools like Code Whisperer is going to play a significantly important role in accelerating this developer agility even further, enabling you to modernize your future better and at a much, much better pace, right? And this is all with the focus on customer experience at the center of it. With that, let me bring in Jonathan Luke onto the stage, please. Thank you.
Thank you, Bala. Thank you, everybody, for joining us today. I appreciate you all coming out and listening to our story. So what I am planning to do is to kind of give you the why, what, who backstory around what we did and what we achieved and why it was important. So first off, just a little bit about me. I'm a software developer by trade. Started out as a developer in an ERP system and sort of rose through the ranks within Citi and ended up being the Deputy Global Director of Software Engineering. And right now my current role is I'm responsible for the North American software engineering teams. So I've been at Citi for about 20 years, so I've got a lot of good experience within this market. So who are we at Citi Electric? What are we, right? We are a full-line electrical wholesaler. We sell wire, pipe, breakers, all the wonderful things that keep the light and the energy flowing in your home and in your office. As far as who we are as a business, we are privately owned. We've been in business for 40 years. We have about 705 branches in North America, and we did just shy of $3 billion of turnover last year, and we have about 2.3 million lines of inventory. So our story, right? We want to talk a little bit today about, moving into event-driven architecture and serverless, and a little bit of where we came from. So speaking of where we came from, so this, like many, existing businesses, you have a big giant bowl of spaghetti that is your software ecosystem. Right now, we have about 7 bespoke products that cover the entirety of our operations within Citi, and they're in all different languages, all different databases, all different integrations, release cycles, things like that. I want to take a second to compliment that it has. These software platforms have driven and grown our business from, where we were a few years ago, which was around 300 million to now 3 billion. So while it worked, eventually you do have to move on and you have to mature your architecture. So here's a little bit of the teams that help support this. I don't know how many of you have these similar challenges. We have teams that are spread across a good chunk of the US and some in Canada. And so we're in 2 countries, 13 states, and 3 different time zones. And we have about 60 plus people supporting all the various platforms and infrastructure that allows these software systems to run. Okay, so with that being said, what are the challenges, right? What are the problems? Why are we here to try to, find solutions? Well, one of the biggest problems we do have within Citi's architecture at the moment is it's not uniform. We have 7 different platforms and 7 different IDEs with 7 different databases, and so it's just all over the place, which breeds or brings in a lot of duplication of work because there's no shareable components. Some of the platforms kind of age out a little bit because, like with a lot of ERP systems, when you get in, it's very tough to get them back out because it's got momentum. So you deal with that aging platforms, no uniform architecture, duplication of work, and so that drives up costs and technical debt, which is a challenge. And then that leads into people, right? So you've got people that are supporting these systems, and with these systems that are very siloed, it's very hard to move people around between those systems. So you have challenges with recruitment, you have challenges with onboarding, and then the other thing that we end up having a problem with is just keeping up with technical trends. So we obviously wanted to make a change, right? But we had to start somewhere. And what we ended up doing is we had Citi, we do a yearly inventory and we call it stock take. And this is where we stop the business for about 12 hours and we count all those 2.3 million inventory, those lines of inventory. And we do this so we can validate the counts in our system. And this allows things to get picked up. So if there's human errors, physical errors, system errors, it allows us to reset that inventory. So why do we do this? Why is it important? So within Citi, we have the luxury of being essentially a profit-sharing businesses. So our employees share in the success of Citi, and then this inventory number feeds into the profitability of the branch, and that then feeds into people's compensation. So it's very, very important we do it right, and it's accurate and efficient. So this is what we do today, this wonderful piece of hardware that is 1 million years old. So it is an old Motorola scanner. If you have poor eyesight or big fingers, you are in a world of hurt trying to use this stuff out in the warehouse. It's a very dumb device. It does batch downloading over serial ports. There's no feedback. There's no interaction. It's a very cumbersome tool to use. And so we said, you know what, we've got to move on from this for many reasons, the ones that I've given before, but also we can't source these things anymore. So we have to move on to new technology. So where do we go, right? What do we want? How do we structure a solution, for this problem? Trying to embrace the new and what we're here and what Lee's going to talk about, while sort of feeding into the old. So here was just a handful of things that we sort of put together to have an outline for a solution, right? We at Citi have a history of building things our own, so we wanted it to be bespoke. We wanted it to be cloud-based. We wanted to make sure that it was modern architecture, something that was reusable, that we can do as a foundational piece of other projects that will come on the heels of this. We also didn't want to go wholly on our own, right? We wanted to leverage existing knowledge within Citi, and Lee will probably talk a little bit more about that as well. And then we also wanted to utilize ProServe and the assistance that the AWS teams can bring. So in regards to that, I don't know if any of you have had the luxury or the privilege of working with the AWS account teams or the ProServe teams. They've been absolutely fantastic and amazing with us. As many of you know, AWS is a massive set of tools and suites and services that you can get totally lost in. It's like an absolute forest. And what those teams do is they help us kind of navigate that forest and making sure that we are pulling the right solutions for the right problem. They also bring in various different type of architects and experts in those fields to really kind of guide us. It's been amazing. And individually, I can't say enough good things about the solutions architects and the technical architects that have come from AWS. They've been incredibly supportive, patient, worked with us, a lot of good stuff. The other thing that they've provided, which has been brilliant, is upskilling and training, right? So we're coming from a very on-prem, legacy type of development environment that you probably all are familiar with, moving into cloud-based. So there was a big effort around upskilling and bringing knowledge and expertise into the teams in which they've been amazing at. We've mentioned a couple of times here, CEF, just to kind of give you a quick background of this for about 10 seconds, 30 seconds, is that this is the founding member of Citi Electric. Citi Electric as a business was founded in Coventry, England in 1951, and it expanded in U.S. in 1983. So we had different businesses at that point, different technology teams, and then they were running into problems several years back, and they started to embrace cloud and serverless, and that's where Lee and others have joined us, and so we were able to kind of lean on their expertise to help guide our journey. So this is kind of what we did, and this is where I'm really most proud of, right? We took all these different challenges, new technologies, new team philosophies, the whole 9 yards, and we were able to build something incredibly quick and incredibly effective and incredibly cheap. So we went from teams that had very little experience to no solution to within 9 weeks, we had a full production-ready application that worked exceedingly well. Us being a little bit reserved and careful, we only did this within 16 locations, and we had 78 end users, but it worked, and it worked fantastically. This is kind of what we did as a quick little screenshot. It was all on Zebra scanners. It was a view front end. It was very interactive, guided journeys, very simple UI, UX for our users. And then the things that also was a benefit now, because it was all Wi-Fi, it was able to interact to our existing ERP system dynamically, so we were able to get feedback back into the scanners. So it was an incredible experience for the users. So in all of this, what did it cost? There's a little joke here, it cost us peanuts. The night to run all these systems cost $4.63, which was amazing, right? Granted, it wasn't the whole business, but it still shows how quick you can develop in AWS and how cost-effective it really is. So here's just some general feedback that we got from our branch staff. The short version of this is they loved it. It saved them hours of efficiency. It worked. It was clean. It was just a really great experience for them. And the syncing with our current ERP systems, it was a fantastic result. The team should be really, really proud. So what's next? Where do we go from here, right? Well, first off, nothing is perfect, and neither are we, and neither was this. And so there was some feedback that we had to go back and address and correct. And so that was a big thing that we were going to be working on. The other thing that we wanted to tackle is scalability, right? So we have 705 stores, and we only did 16. So we've got to scale this out by 30x or more. There were some bits around the code that we kind of took shortcuts on, as you do in a 9-week timeline, right? You got to go quick, and you've all probably have been there at some point where you kind of beg, borrow, and steal to get through and hit the deliverables. But there are some things we wanted to go back and revisit. And then, like every other product, we want to make sure that we are continually improving this product and making it better for our users. So we're going to add, obviously, more feature sets to it as we move on. So I'd like to introduce Lee up onto the stage now.
Hi everyone, so my name's Lee Gilmore and I'm the Global Head of Architecture and Technology at Citi. And what I'm going to talk about is the global tech strategy that allowed us to build this out in 9 weeks. The teams previously hadn't used serverless, AWS, or TypeScript, and did really well to get this out production ready. So what we're going to talk about is these 5 key areas. So we've got serverless first, supported by AWS, domain-driven design and team topologies, EDA, so the event-driven architecture strategy, our evolutionary architecture, and then we're going to touch on the global tech radar. So serverless first, supported by AWS. So historically, we come from data centers and VMs with Citi, CF, and CES. Now, this move to serverless allowed us to be really quick to market. We could innovate, and we could get this out very, very quickly, and then iterate on these particular designs. And we also had reduced operational complexity, so we're not having to patch servers anymore. That's part of the shared responsibility model with AWS. And what this gave us is massive scalability and obviously high availability too. And now we've got a future-proof technology stack as we move away from Sybase and Delphi to TypeScript, CDK, and serverless technologies. And as Jonathan talked about earlier, obviously we've got lower running costs for anything that we actually run in the cloud. And just to note here, we actually built out our reusable reference architectures as well. So we've got something called the Citi CDK, where we can actually start to package these parts of IAC and take the cognitive load off teams, actually allow them to utilize this through an NPM package. And although we are serverless first as a mindset, it is still buy before build. So if there's no competitive advantage in building something out, we're just going to buy that off the shelf. And as Jonathan said earlier, obviously we've been supported by AWS ProServe. So 18 months ago, we had some initial wins in the UK. Teams were very siloed. They'd done some small MVPs, got that out, and it was a learning curve. But there was no reuse, no standards really in place. So when myself and ProServe first started 18 months ago, we did a gap analysis. And this allowed us to move towards a cloud target operating model. So we generated a backlog of work for that. And they also supported our reference architecture. That actually included being on site and doing whiteboarding sessions with us. And obviously training and upskilling. So lots of immersion days and actually working with the teams to help upskill them. And as I said before, this has allowed us to move to what we call the City CDK. So taking the cognitive load off teams and having these reusable building blocks of code which they can use. And coming from a data center, it's very different to running in the cloud. So they also supported the security teams with best practices and standards. So once we did all this, we then started looking at actually what we're going to build and who is going to build it. And this is where we looked at domain-driven design and team topologies. So this is a great quote from Eric Evans. He wrote the original Blue Book, for anyone that's read that. And this quote really resonated with us, which is the heart of software is its ability to solve domain-related problems for its users. And that's what we need to do. We need to go back to what is the actual problem that we're solving through these serverless architectures. So domain-driven design aligns real-world business domains with real-world problems with architecture and software engineering. So we're actually building something that the customer wants. And it places the key focus on the core domains. What makes us unique? Where's the competitive advantage? That's where we want to focus our efforts. And it also promotes continuous collaboration between technical, so engineering teams, and domain experts, i.e. the customer. And they agree to these models and they refine them. So we're all on the same wavelength with what we're actually building. And it also allows us to understand the key domain events. So what are the significant changes that are happening within the domains? So I said the word domain there a lot of times, but what actually is a domain? So if we went to the Cambridge Dictionary definition, we'd say things like an area of interest or an area over which a person has control. You'd better ask Paul, electronics is not my domain, I'm afraid, and boardroom decisions are the exclusive domain of company directors. So if we looked at tangibly what that is, we've got fuzzy interpretations of interest and meaning. We've got boundaries for language and concepts, and distinct boundaries are ideal for system design. So good fences make good neighbors. That's a common quote that most of us would have heard of. So then we've got this notion of our overall domain. This is city, and this is very complex. This is across manufacturing, warehousing, sale, customer. And if we went to build this outright, we'd build a complex monolith, a big ball of mud. So what we typically do is look at things like event storming and context mapping to start to break this down into smaller subdomains, and we've got a few of those listed there. And as we do this, what we find is there's three types that we need to look at. So we've got core. Now, this encapsulates what makes you competitive, what differentiates you with your competitors, and this is where you want to spend about 80% of your engineering effort. And then we've got supporting, so these support the core domains, but don't really have value on their own. And these don't really affect the competitiveness. And then we've got generic. So this is typically where it's very complex to build, and more often than not, we're just going to buy this off the shelf. So to bring this to life a little bit, at City, we would have core domains such as order fulfillment, product, customer, and price. This is very unique to what we do at City. It makes us competitive. We've got supporting things like data, BI, integrations, and messaging, which underpin everything we do in the core domains. And then we've got generic things like finance and HR. Everybody uses the same systems pretty much, so we're just going to buy that off the shelf and integrate into the other systems. So as we start to break these down into these different subdomains, what we typically do is look at the domain model. So this is your structured knowledge and problems within the domain. And this is made up of rules and languages and concepts, and that's key here. It's all about language. And it should identify the relationships among all of the entities that happen within the scope of that domain. And it's typically modeled with things like Post-it notes, if you're doing event storming, or it could be pseudocode and diagrams. And this is to make sure we're all on the same wavelength with what we're building between the customer and the engineering teams. So it's just a construct to allow that. And as we start to build out these subdomains, we've then got the notion of bounded context. So a bounded context is the boundary of the subdomain model, and it's always desirable to have a one-to-one mapping between the domain model and the bounded context. So the subdomain, therefore, equates to the problem space, so the language and the concepts and the rules within that subdomain. And then the bounded context is the solution space. And this is where we're going to build microservices. And one team should build and maintain within that bounded context because we want to limit dependencies on teams. We want them to do a full slice of the work. And one team, however, could actually own multiple bounded contexts. So again, to bring this to life a little bit, we can see a simplified diagram here. So we've got HR, that's generic. We're just going to buy that off the shelf. We've got data and BI. That's a supporting subdomain, so we're going to probably have a one-to-one ratio between build and buy. And then we've got price and customer, which are both core. This makes us competitive, and we're going to spend a lot of engineering effort in building these out. And we've zoomed into customer a little bit there to see the domain model, which is in yellow there. And you can see for the customer subdomain, this part of the overall system, this is where we've got language, processes, and rules. And you can see that red dotted line around the edge, and that's the bounded context. And that's where we're going to start building out these microservices. So we can see here that within that bounded context, it's well encapsulated. We can see that we've got one or more microservices that are communicating within there. And they can communicate privately between themselves. They might have private domain events there, but all of that is fully encapsulated. So the only way that we actually talk to other domains is either expose certain functionality through REST APIs or through raising public domain events. And one thing that's missing from that diagram is typically we would have an EventBridge custom bus in there as well at City, and that allows us to also consume domain events. So now we're looking at team topologies, and this is a great quote from Matthew Emmanuel, who wrote the book on team topologies, which is, choose software architectures that encourage team-scoped flows. So how do we allow teams to work very quickly? So team topologies is an approach to organizing business and technology teams for fast flow and limiting the dependencies between them. And there's 4 fundamental team types that we need to align to. And this helps reduce the cognitive load on teams and streamlines the interactions between them. So these are the 4 fundamental team types that we've aligned to at City. So we've got stream aligned. For us, that would be our domain teams, or in some companies, this would be product teams. And these are long-lived teams that typically work on a backlog of work. And then we've got the notion of enabling teams. And these are teams that help support the stream-aligned teams. So this could be, for example, architecture or UX practices. So we might want to actually have architects work with the team, help upskill them, overcome certain problems, and then step back and let the team work away. And we've got complicated subsystems, which we don't actually have at City. This is where we've got significant mathematics, calculations, or technical expertise needed. And then finally, we've got platform teams. So this is teams that build internal developer platforms. Again, this supports the stream-aligned teams and allows them to move quicker. So how has DDD and team topologies affected City as an organization? So we can see here that we've got our enabling teams in yellow. So we've got enterprise architecture. Typically, they're looking at the North Star architecture and supporting the stream-aligned teams and moving to that. We've got the architecture enablement team and the architecture practice, engineering, UX, and QA practices. So again, supporting and upskilling those stream-aligned teams. And we can see the stream-aligned teams there running left to right, the purple ones. So these are our long-lived domain teams if we go back to DDD. And underpinning all of this, we've got our cloud engineering teams who build out all of the platforms for us. And if we overlay the DDD aspect onto this, we can see our core domains. We've got things like product and price, customer and sale. This is where we're going to spend a lot of engineering effort. We've got supporting things like the common component team and BI and analytics. And then we've got the generic subdomains. These are things that we're just going to buy off the shelf typically. So if we then zoomed out and looked at the high-level architecture at City, now we call this serverless architecture layers or SAL architecture. But you can see at the top we have channels. This could be ADI, this could be chatbot, it could be web or mobile. And they only communicate through this experience layer. So this is back-end for front ends typically. These don't have a lot of business logic in them, and this is just the interface into the domain services. So we can see there we've got integration APIs, B2B, and web and mobile. And they then talk to the domain services. These are private to the AWS network, so we use Private Link to actually talk between them with SigV4 and IAM authentication. And what you can see here, going back to team topologies, we want the teams to do the full slice. So with the branch WMS project, the team did the front end, back end for front end, and the back end warehouse API changes. So we don't want to have dependencies between teams. We want them to do the full vertical slice. And then we've got our data layer. So we can see we've got our enterprise service bus, and we've got things like our data lake and data warehouse. You'd also have machine learning and AI in this area. And then we've got the platform layer. So this is where we've got things like developer experience, landing zones, and pipelines. Everything that's supporting the teams above with undifferentiated heavy lifting. Again, we want the teams to move very quickly. So spinning up an AWS account or equivalent should be very quick. And then on the left-hand side, we've got our cross-cutting. So this is typically something that affects everything within an organization. Things like logging, tracing. We've got our own SDK, and obviously we've got our City CDK that I talked about earlier. And this is managed through an enablement team. So this is our common component team who build these out. So we saw an ESB on there, and a lot of people will be thinking about SOA-style architectures, which we don't actually have at City, but you can see we're now going to go on to the EDA side of it, our EDA strategy. Now, Bala talked about this earlier, and this is a great quote from Werner Vogels as well, that everything fails all the time. And this is why we want to decouple our serverless microservices. So the EDA strategy that we've got has allowed us to have decoupled domain and experience services. So typically we only communicate through events. There are always times we need to do synchronous calls through REST, but it is event-driven first where we can. And this enables these services to scale independently. And the events are based on our domain models, going back to DDD that we talked about earlier. And again, Bala talked about this earlier, but we can utilize error handling, so things like DLQs. So when a service comes back online, we can replay the events, and again, the customer's not affected. So I said the word event there quite a few times, but what is an event? So there's two types that we use at City. So we've got a typical event. This is a domain event. It's something that's happened. It's immutable. It's in the past. This could be order created or invoice generated. And then we have the notion of a command, which we don't use a lot at City, but this is where there's an intent aimed at another domain, something like send email or generate PDF. Now, I won't read this verbatim. This is a quote from AWS about an ESB. But what this typically is allowing different services to communicate through events in a standard way. So going back to serverless architecture layers, we can see in our data layer, we've got our ESB, which is Amazon Event Bridge. And we can see that we have events flowing between the experience layer and the domain layer there. And to bring it to life a little bit, we have things like payment canceled, order created, user logged in, or product updated. Now, the reason we call it an ESB is we use something called the single bus multi-account pattern. So you can see on this diagram, you've got a central event bus that everything flows through from an event perspective. And then we can see we've got the blue, orange, and purple teams here. And they're publishing domain events to the central event bus, but also consuming to their own local event buses where they need to. So we've got that asynchronous two-way communication. And again, zooming out a little bit and having a look at an example at City, we can see our Stream-Aligned team has an experience layer. And you can see this is our customer web app, and it's publishing domain events which are going to our data layer, so our ESB. And this is our shared Event Bridge account. And then we've got target rules that route to our domain layer, so these private domain services. And these, again, are looked after by our Stream-Aligned team. And we can see the orders domain might do some processing, and the customer service might do its own processing off the back of that. Now you can see the customer service, the domain layer, is then publishing back to the main event bus, and then that's being consumed again in the front end. So you might use something like AppSync subscriptions. And you might want to do that in real time and give some kind of update to the user, or maybe cache some kind of read store in the experience layer. So the key learnings for us using Amazon EventBridge is you haven't got guaranteed ordering. So when you need to do this, you need to look at SNS and SQS FIFO patterns. There is a way of using the two in conjunction. If anybody's interested, you can grab me after the talk and we can talk that through. So publishers should always validate the events. You should be a good event citizen because a lot of other domain services are going to consume that event. But at the same time, you should always validate anything you consume. And Amazon EventBridge supports at least one semantics, and that means you could get the same event multiple times. So your downstream services have to be idempotent. They need to be able to ignore the subsequent events. What you don't want to do is charge a customer twice or maybe send an email 3 times. So we've went through very quickly there the strategic side of DDD, and now we're going to look at the tactical side. So we're going to look at evolutionary architecture. So again, this is a quote that resonated with us. This was by a guy called Robert C. Martin, or Uncle Bob, as some people know him as. And this is when any of the external parts of the system become obsolete, such as the database or the web framework, you can replace those obsolete elements with minimum of fuss. Now at City, we knew this was transient, so to start with, we would call through to our monolithic API. We knew that over time we'd gather insights and we might want to swap out certain AWS services for other ones. And we knew as we broke down our monolithic API, we'd break it down into domain services, and that meant we'd have to start changing different HTTP calls, hitting different REST interfaces, and we'd have different DTO objects coming back too. And some of these services that we build might be more applicable to containers, some might be more applicable to functions, and vice versa. And we only find out sometimes when they're in production, we've actually got some kind of scale going through them. And again, for the same reason, we can't know all data access patterns up front. So we want to be able to swap out a certain database during development if we need to without a full rewrite. So at City, we've got 2 types. We've got the lightweight version of hexagonal architecture, and then we've got the full version. Now, we can't talk through the full version today because it covers things like repositories, use cases, aggregates, aggregate roots. That's a talk in its own right. But we'll talk about the lightweight version. So we use this typically when it's more of a CRUD-style service. It could be in our experience layer or an integration. And the full version we typically use when there's a lot of business logic in there, a very heavy domain model. So if we look at this example here, we can see we've got API Gateway, which is invoking a Lambda function. That's what the purple circle denotes. And we can see that we've got primary adapters on the driving side. So this is some kind of input that's coming in. So this would be taking the event from API Gateway. It would be transposing it, maybe doing some kind of instrumentation and logging, and then calling the use case for the business logic. And eventually that's going to return the status code and the body back to API Gateway. So this is completely devoid of any business logic, and it's completely just framework. But as it calls the use case, again, this is vice versa. It has no notion of frameworks. It is purely domain logic. And this will have to persist data or retrieve data. So we've got DynamoDB here, and that does it on the driven side through something called secondary adapters. And we can also see that we're publishing a domain event there to Amazon EventBridge. Now, the beauty of this comes in where we might want to go with a storage first pattern. So we might want to go from API Gateway to SQS now, and then Lambda. So all of a sudden, we've got this primary adapter that needs to understand SQS. So what we typically do is write a new primary adapter for SQS, and we can slot that in very easily, and nothing else changes from left to right. And then if you look at the driven side, you can see that we might want to swap out Amazon EventBridge for SNS. Again, we can create a new secondary adapter for SNS. And with it being ports and adapters, we can just unplug the EventBridge one and plug in SNS very easily. Now, if we'd done this as one big Lambda handler, this would have been pretty much a rewrite. And then if you extrapolate that out across maybe 100 or 1,000 Lambdas, that's a lot of work. So I just want to touch upon the global tech radar that we've got at City because this has really underpinned what we've done. So a global tech radar is something that was created by ThoughtWorks, and this allows us to look at these 4 quadrants, so tools and techniques, platforms, languages, and frameworks. And then we've got these rings, so we've got adopt, Now for us at City, this would be things like TypeScript in the CDK, and this is what we want teams to go to anytime they build out a new service. But then we've got the notion of on hold. So we don't want to do any new development with Sybase or Delphi, and this makes sure that we're all on the same wavelength with what we're building globally. And things like GenAI might be in assess, so we might look at Amazon Bedrock, for example. And as we start to use this a little bit more, we might put this into trial. And eventually, as we use this in more and more services, and we think we get real value from it, we can move that to adopt. And that way, as a business, we're all aligned to what we're actually building. And this has really supported our common component team. So they're building things out like our City CDK, so the composable architecture. Now, if we had teams using Terraform and serverless framework, they wouldn't be able to use this particular framework that we're creating. And that's exactly the same with our front-end components as well in our design language. So we did this over 18 months in the UK, and this has really underpinned the first bit of work that we did in North America, which is our Branch WMS project. So we needed to use the agility and speed of serverless and really thin slices. As Jonathan said, we had quite tight timescales to get this out. And we knew it would take time to strangle the monolith that we have in North America. So the first iteration was going to be to call through from the experience layer through to the domain layer. And future iterations over time would then call out to the domain services as we start to break those down. So that means we had to have evolutionary architecture. We wanted to make this really easy for ourselves. And we used the patterns, best practices, and reference architectures that we'd built out over the past 18 months to really underpin the work that we did in North America. And the North American team also aligned to the tech radar, which meant that they could start to utilize the common components that we had. So this is a very simple diagram. There's a lot of services that have been removed. There's only so much I can get on a slide. But you can see here we've got a scanner device. So this is somebody doing the stock take. We can see we've got AWS WAF because we want to make sure that we restrict the use of this down to the actual branches. The Vue.js app is in S3, and we've got a CloudFront distribution there. And obviously, there's other services at play like Route 53. And there's also authentication, so it's authenticated with Azure AD. And then we've got API Gateway, as you can see there, calling through these Lambda functions within a VPC. Now, the reason we've got the Lambda functions in a VPC is because typically, as I said earlier, the communication synchronously is using SIG-V4 and IAM. So we keep everything private to the AWS network. And again, going back to DDD, we can see these Lambda functions are raising public domain events, and they're going to our shared EDA account, so our shared Amazon EventBridge bus. And we've got gateway endpoints and VPC endpoints there for talking out to Parameter Store and DynamoDB, again, keeping it private to the AWS network. And we've got a NAT gateway there because we want to make sure any egress is all on a static IP address. And this allows, on the right-hand side, the on-prem API to allow list this particular experience layer. And again, as that's fully authorized, you've got machine-to-machine flows there, so client credential grant flow between the two. So I'm now going to invite Bala and Jonathan to come on stage and talk about what we actually learned as part of this project.
Thanks, Lee. So obviously there's a lot of work went into this across the board. And, you know, excuse me, like everything else, there's wins and there's losses and things we did right and things we did wrong. The thing that I want to most focus on is the fact we did it. You know, we took a lot of these concepts, we took a lot of this new technology, and we found a way to deliver a solution in a very quick and efficient way that had very minimal cost impact, which was sort of impressive. The team did an amazing job working together, rallying around each other to deliver the solution with all the different supports coming from AWS and from our colleagues in Europe. But like everything else, there's things here that don't work as well. So we did incur some technical debt, like we mentioned before, that we had to go back and correct and clean. That was a little bit of a siloed approach, kind of. We needed to do that in order to get it delivered. And then a lot of the processes that we had were ad hoc, right? So we kind of had to go back and look at restructuring them to have them being a little bit more formalized. And their ways of working. So, I mean, at the end of the day, we delivered value to the business. We did it in a modern architecture, utilizing cloud services, and the teams were able to sort of hit their mark, which was an impressive result. So, I'm very proud of what everybody has done. And thank you all for coming. We appreciate the time and the effort.